This week on the podcast, what can I say about Peter Rawlinson? Not only is he the guy who developed the Model S from a clean sheet of paper for Tesla, but he's the man behind Lucid. He joined as Chief Technology Officer and eventually became CEO and drove the launch of the Lucid Air, probably the most awarded car in the modern era. It has sucked up every single accolade that you can have for either an electric or traditional car. 500 miles of range, 1,200 horsepower on their top of the line. Not only that, they have a mid-tier car that's about half the price of the six-figure one. They're aiming to release an SUV towards the end of this year and a low-cost car in the $40,000 to $50,000 range in the coming years. This is a fascinating company. Rawlinson has an amazing history in the industry. Lotus, Jaguar, Tesla, and now Lucid. I thought this conversation was absolutely fascinating, and I think you will also. With no further ado, my conversation with Peter Rawlinson.
Great to be here, Barry.
Great to have you. So let's start a little bit with your background. You went to Imperial College at the University of London. Was the career plan always automotive engineering, or what were you thinking?
I didn't know what I was going to do. I considered art school or something creative. I knew I wanted to design things, and in the end, I did a mechanical engineering course because it gave me the greatest optionality.
Imperial College has some amazing alumni. Sir William Crookes, who invented the vacuum tube, H.G. Wells, Peter Higgs of Higgs boson, Sir Alexander Fleming, and penicillin. What was your experience like at Imperial College?
Well, it was quite an experience for a kid from Wales in the big city.
Mm-hmm. So let's talk a little bit about your automotive background. Chief engineer at Lotus Cars, principal engineer at Jaguar, two storied marques. Tell us a little bit about your experience with both of those.
Yeah, I mean, it was a wealth of experience. I think that if we look at my days at Jaguar, it was a fascinating period because it was the dawn of the use of computers to design cars. Up to that time, cars had been designed on drawing boards.
Manually, paper.
Yeah, absolutely. We're talking 1980s. And I was very fortunate that Jaguar made a big investment and a big push to pioneering the use of computer to digitally design a car. And it had never been done before, seriously. I was one of the first people in the UK to use CAD, computer-aided design, prior to Jaguar. But it was at Jaguar that we really started using it in earnest. And we used it in a joined-up way with CAE, computer-aided engineering. So we could do the stress analysis by finite element analysis, which was all new stuff. It was cutting edge. And we found a way of transferring files from colleague to colleague, from their computer, from terminal to terminal. And effectively, we developed our own intranet, which is known as an intranet now. Well, this is long before the internet.
Right.
We didn't even have a name for it. And we were just transferring files. And we created this methodology of a digital process to design a car which was totally revolutionary in terms of how all the systems were designed, the parts, how the designs were shared digitally, and how they were analyzed computationally for stress and crash performance.
So technology has been a core part of your process for bringing cars from a clean sheet to actually a sellable product.
Totally. And I've been fortunate. I've always worked until more recent years at the cutting edge in advanced engineering. I was responsible for advanced engineering at Lotus, and at Jaguar I was responsible for advanced body structure design. And it's that sort of technological advancement that is really central to my career and my being, really. And also trying to do kind of the impossible with very small teams of people, super smart people, very joined up, everyone knowing what's going on, and the power of kind of an elite team of really capable people, kind of like special forces.
I love that analogy. So you go from Jaguar and Lotus in 2010 to Tesla. as VP of Vehicle Engineering and Chief Engineer of the Tesla Model S. When you arrived, that was a clean sheet piece of paper, right?
Yeah. Well, I joined in February 2009, way before 2010. It was formally announced quite a lot later after that. But I actually spoke to a guy called Elon Musk, who called me in England in January, and went out and met him in January 2009. And I was there in the company in February 2009, long before there was a conceptual prototype of Model S out.
Back in those days, it was a little Lotus Elan where they took out the engine and dropped in a bunch of batteries and electric motors.
Yeah.
It's hard to imagine that beginning eventually led to the Model S. And while the Model S is certainly long in the tooth, it's been around a while, when that car came out, it was pretty innovative and unique in the world. Tell us about your experience helping to develop the Model S, the car that arguably changed the entire automotive world.
Totally. Well, it was a labor of love. I was working crazy hours. I was working regular 100 hours a week to achieve that against all odds. And so when I joined the company, a start had already been made. They'd been working on it for about a year, and it was a false dawn. It was never going to work. So I had a difficult decision to make the first week I was there. I had to go and tell my new boss, that it really needs to start again with a clean sheet. And he had the wisdom to agree with me. And so we started afresh on Model S from the ground up. And that was probably the second week of February 2009.
And then the car comes out in 2012? That's incredibly rapid.
It was record time. And it was a crazy, because I actually had a team of about 6 people to start with. Everyone had left. And it was obvious I had to start from scratch, from a clean computer screen. So I had to hire the team, attract people to this company that no one had heard of, which no one gave a shot of being successful at.
There was certainly a lot of skepticism in the early years.
Totally. And there was this misconception there wasn't sufficient expertise and experience to do a car, let alone something which was really cutting edge. But actually, having that clean sheet and having the authority, the go-ahead to recruit my team and handpick my team, that's what changed everything. Because I could actually handpick an elite team of the best engineers in the world. And I called everyone I'd worked with before. That's why a lot of Brits came out and designed Model S. It was very much an international effort, but a lot of British people, because there's people I knew from my past.
From Jaguar, from Lotus,
exactly,
from Corse.
Exactly. And really, we set up Tesla Engineering. There wasn't a place to do it. And I was actually working in SpaceX. I had my SpaceX security pass, and I found that the second floor of SpaceX was unused. It was early days at SpaceX. And it was just concrete floor. And I said, can I have this? Let's set up Tesla Engineering upstairs in SpaceX.
Wow.
And we rolled some grey carpet down, put some desks there, and probably about 20 of us actually designed the Model S from the ground up through 2009. And then eventually I grew the team to about 150 people through that 3-year period. But it was a fascinating time. It was when Tesla was at the cutting edge. And the interesting thing was that the person who drove me the most was myself. Because here I had this incredible opportunity in life to show what was possible and show what I could do. And really, one of the main weapons I had was digital engineering. To take everything I'd learned about cutting-edge computational engineering and simulation, digital wind tunnel, digital everything. So therefore, we could actually go late on prototypes and effectively go for computational prototypes tens of thousands of times to get things right. So when we actually built a proper prototype, and the first proper prototype was late 2010, relatively late, and this was a core philosophy of my engineering process, to really turn things on their head. Normally, there's an emphasis on getting an early prototype so you can learn early with your mistakes. My process was the absolute antithesis. Make all your mistakes on the computer, test it 1,000 times, 10,000 times, and then cut the metal when you're damn sure, relatively late, and that prototype will be really good. And that's what we did. And that's how we reduced the time scale. And that car was in production 3.5 years from the day I said, right, let's design it from scratch, back in February 2009.
So we're going to talk a little bit more about Tesla later, but you said something that caught my ear. At the time, the 09 to 12 era, Tesla was at the cutting edge. You're implying they're no longer at the cutting edge. Is that the case?
I think that the mantle has passed to Lucid. I think Lucid is now at the cutting edge.
Huh.
I think we are the company with a true sense of mission. This week I was proud to announce that we'd created a landmark number in the development of the EV, which is going to have a profound impact upon the planet, and that is achieving 5 miles of range per kilowatt hour of energy.
That's a giant efficiency.
It's a giant leap forward.
Like a lot of the cars out there are 2-ish if they're lucky, 3.
2. You're very well versed in this, Barry. Absolutely.
I'm a car guy, so
and,
I know this.
You know your stuff. And why this is important is that we need to address the barriers to widespread adoption of electric cars. And the first barrier was range anxiety. When we launched Lucid Air in the fall of 21, we had a range of 520 miles with our very first product. Nobody believed it was possible. And we did that with a modest battery size. It wasn't it wasn't dumb range with just stuffing loads of batteries in. Anyone can do that. And this is cutting edge stuff. And why this is important is the next barrier to widespread adoption is the cost of ownership, the cost of an EV. Why not everybody jumping to EVs now? It's because of cost.
Clearly.
And if you look at the breakdown of the cost of building the bill of materials of all the parts that you put into an EV, for a high-end EV, about 37% of that value is the battery pack.
Wow.
But for a more affordable family car, it's over 40%. There is no gasoline engine car equivalent to this imbalance of cost. So what we're doing at Lucid is addressing the cost of the batteries. And we're doing it in an unorthodox way. Rather than saying, right, can we make batteries cheaper through an economy of scale? We're actually saying, do we need that many batteries in the first place? Can we go further with higher technology? We've reinvented the electric motor. We've reinvented the inverter to go further with less batteries in the first place. And so if you look at our products today, if you look at the Lucid Air Pure, we're able to do the car that's in production right now. For any journey you take from A to B, whether it's from home to the office, down the shops, on your vacation, you will use less electricity to go from A to B than any other car on the market today, bar none. And because it's the most efficient, and because you're able to use less electricity, not only will it cost you less as a user, but it means you don't have to carry such a large battery pack around. And that means better use of the world's precious resources, less mines for lithium, nickel, cobalt, less dependence geopolitically in this world for the US. And this is of a profound significance. We can go further with less through technology.
Let's talk a little bit about what led you to join Lucid. You helped bring out the Model S. You were chief engineer of the Model S project when you were at Tesla. So let's start with that car. Not only did you bring it to market incredibly quick, it won multiple awards: Automobile Magazine Automobile of the Year, Motor Trend Car of the Year, all sorts of big wins. What made the Model S so successful?
I think it was the big picture thinking and right down to detailed execution. I think you need to have both. I think you need to have a strategic oversight of joined up thinking of how systems interact relative to each other as a complete ecosystem. And then you need to have that loving attention to detail I'm well known for my mantra that every millimetre counts, and I felt that every gram counts, particularly with an electric car where every joule of energy is a precious commodity. So it was really a very interesting intellectual puzzle, because when I arrived at Tesla in February 2009, prior to my arrival, Franz von Holzhausen, who was the design chief, arrived around, I think it was about autumn 2008, August 2008. And before I'd arrived, the exterior styling design, the shape of Model S, had been signed off and approved between Franz and Elon. And that was pretty well predetermined before I arrived. Now, that set in stone effectively the outer shape constraint, the parameters that I as an engineer could work to. Now, that's very different from how we approach Lucid Air, and I can go on to that later. But this presented a very interesting and compelling intellectual puzzle, a 3D puzzle. How was I going to fit all the battery cells in to give that car, to endow that car with sufficient range? Mm-hmm. How was I going to fit in motors, transmission, drive shafts, suspension, people package, legroom, crumple zones, cooling, just space for luggage, all of that within that predetermined outer shape, because it'd been signed off, and I realised within a millisecond that wasn't going to change much. So it was a fascinating three-dimensional puzzle. It was like a Tetris on steroids, to solve how we were going to fit all these parts in the car. And I can give you a very interesting example. We wanted to have a flat floor in the car to differentiate it, no transmission tunnel
right, exactly.
inside the cabin. And a traditional car's got a transmission tunnel at the rear, and of course that is an obstruction to comfort for the occupants.
Especially that middle seat in the back. Sure.
Absolutely, exactly. And so there was a desire to have a fully flat floor. But one of the big loads that you have to design for structurally in a car are the seatbelt pull tests, particularly the lower anchor points which go through the seat and through the seat mountings into the floor. And so a flat sheet metal floor wouldn't have been strong enough. So it was very clear we'd have to link the battery pack structure under the floor through and make the battery pack contribute to the seat belt strength. The
structural rigidity.
Yeah, exactly. So the seatbelt loads would go through the floor, through a long bolt, through the cross member, which is in the battery pack. Huh. And these had to go in a specific location where the people fitted. And so that starts determining where you can put the cross members in the battery pack. So when I started laying out the architecture of all the cells fitted in that battery pack, I noticed that we could actually divide that into 7 elements along the rocker section, and we'd be able to get these cross members in precisely the right point. And why this is a very interesting example of joined-up thinking is that then led to the design of the module of the battery pack, and we ended up with 16 modules of 450 cells on the Model S. And actually it had a determining factor upon the voltage that the car ran at. Can you believe that? The seatbelt anchorage structural loads start splitting up the pack into discrete modules which influence the electrical voltage. That's truly joined-up thinking.
One thing leads to the next, which leads to the next, and every decision you make has ramifications for everything else.
Totally. And it's not the only thing, because we knew we didn't have silicon carbide switching technology in those days. So we were using insulated gate bipolar transistors, which was limiting us to, around 420 to 430 volts. So we knew what sort of range and we knew there could be some peak overloads, that voltage spikes that we had to cover for. So we knew roughly the voltage range that we could hit, but it was sort of absolutely consistent with how many cells could we fit? Because each cell had an amount of energy, and so the number of cells would determine the range of the vehicles. You wanted to get us maximize that as well, and even the gaps between the cells. And I was able to do that without changing the wheelbase of the car from the original design, which was quite an achievement, I can tell you.
So now let me pull you back from the engineering wonkiness. You come off of the giant success of the Model S. What made you decide, hey, that was fun, let me go elsewhere and start with a clean sheet rather than stay at Tesla and work on whatever their next vehicle was going to be?
I'm glad you asked me that, because there's a sort of interlude between the two. So while I was doing all this, my mother was living in England, and she's a widow, and she was in her 90s, and her health was failing, and I just had to go back. So I resigned my position at Tesla in January 2012. I went home for Christmas end of 2011, and it was clear that Mum needed me. And so I gave up my job at Tesla, flying around with Elon on his jet, and I went home and I was literally cooking dinner and washing the dishes for Mum. And then it's only when she passed that I really came out and joined a little company and set up Lucid from it.
So were there any regrets after not going back to Tesla? What did Elon say to you? You were a key person for the success of the Model S. He recruited you. How did he feel when you said, I'm going to do something else?
Well, he did have the good grace to ring me up and ask me to come back, but my decision was made. Yeah.
So what was it like working for Musk? He's got a little bit of a reputation. How was your relationship? How did he affect what the Model S turned out to be?
So it's very interesting. I think there is a common narrative that he pushes everyone, his subordinates, really hard.
True.
I never had that experience.
Really?
Because I pushed myself so crazy hard to do it that there was someone pushing me harder than he ever could, and it was me. Because I'd had years and years of wanting to do something like a Model S, and I could never have done it at, say, Jaguar or Lotus. But what I had was the freedom of hand-picking brilliant engineers. And he was totally aligned with that. We totally had a shared vision, and SpaceX was built upon that, and I was working in SpaceX, that one great engineer is worth 100 mediocre people. It's all about how can you attract the best brains on the planet to come with a sense of mission. And that's what I did. And actually, I remember I actually even had a math test for all my candidates. And it was like, never mind what qualifications you've got, do this math with me. Poor people. I put them all through the ringer. And I personally interviewed everyone. And actually, I built Lucid that way. I mean, I don't these days. But if you look at the core capability, the core engineering talent at Lucid, and many of them been with me for many, many years. And a lot of my Tesla Model S team came across with me. And literally, we've got hundreds of people who have come across from Tesla to Lucid. Lucid's like a beacon of light now. Hundreds of people have come across, and they're drawn to this flame that we are going to be the best technically, whatever it takes.
We're going to get into Lucid in a few moments, but you mentioned SpaceX. I have to ask you a question. Not only is Elon Musk running Tesla, he's running SpaceX, he's running Twitter, or ostensibly he handed it off to somebody, but it's pretty clear he's still very involved. He's running XAI. That's 4 companies. How can one person successfully manage running 4 companies? Steve Jobs ran Apple and Pixar, and he was pretty hands-off at Pixar.
Well, I think there is a worrying distraction there, and I think that's why the mantle has been passed to Lucid. I pledge to my whole team, my investors, all our shareholders, that I'm fully committed to Lucid alone, and I'm all in on just one task, one company. And that's probably why you hardly ever see me in the media, because it requires that degree of commitment to set up a car company.
So the implication is, if you're running 4 companies, and I don't want to put words in your mouth, but are you implying he has taken his eye off the ball at Tesla?
I think that you've got to look at who is now leading technically. I mean, we've got the highest voltage car, we've got the most efficient, we've got the most aerodynamic, we've got the longest range, we've got the highest performance, we've got the best battery engineering, we've got the most advanced motor control algorithms. I think we've got the best battery management system, control system on the planet. If you look at all the breakthroughs that we're making, it's very clear that back in 2009 to 2012, Tesla was doing that. And today, right now, it's Lucid that's doing it. And someone needs to carry this torch forward for the benefit of all humanity, and we're happy to do that.
To me, the thing that perplexes me more than anything about Elon Musk is if my product that I am trying to sell is supposedly going to reduce global carbon emissions and adapt to better outcome for global warming, why tack hard to the right and get in bed with people who think global warming is a hoax? Like, your client base are people concerned about global warming. I don't understand the whole right-wing trolling, crazy sort of stuff that's happened over the past year with him. You've watched him. I know it's been a good long time, but any explanation for what's going on there?
Well, I think it's a worrisome trend of distraction. I'm an engineer and a scientist, and I believe there's compelling, overwhelming evidence that global warming is real. It's happening all around us. You'd have to be blind not to see that. And I'm all in committed to doing all I can. I will not rest to use my life energy to try to help this generation and future generations. And this is the sense of mission that we carry at Lucid to really advance the adoption of sustainable mobility. And we have to do that with a sense of utter urgency. And these distractions have no place in that mission for me.
Really interesting. When the Model S came out, I know it was less than 5 years to make it, but it seemed as if the technology built into the Model S was 10 years ahead of everybody else. Maybe 7 years, but nothing else was like that. In terms of the over-the-air updates, the interface, the visual camera system, the self-driving, how big of a lead in any of those technologies does Tesla have? Or are you suggesting that they're pretty much number two or worse in all of those technologies?
In virtual that you've mentioned, they're behind us. We're about 4 years ahead of Tesla. I would say that in terms of autonomous driving capability, they're marginally ahead of us, but not a long way. They're not at level 3. They're at a level 2 plus something. They're a little bit ahead of us, but that's very deliberate. I've chosen to be a fast follower. But if you look at just about everything else, we're significantly ahead in the core powertrain technologies, and also some of the, you mentioned over the air. Let me give you an example in terms of that. When we launched Lucid, and a lot of people don't know this, we launched Lucid Air in the fall of 2021 with a revolutionary 12-volt architecture that we embodied a nodal Ethernet data superhighway in the car. That was in late 21. More recently, Tesla has finally got to that with the Cybertruck. But many people don't realize, they think it's an innovation of Cybertruck. It's actually, Tesla did it 2 and a bit years after Lucid did. Lucid innovated with that, and Tesla followed. If you look at our OTA capability, it's without par.
Over-the-air updates?
Over-the-air updates. We've done about 75, 80 updates. They're coming regularly, thick and fast. And let me give you an example. We've pioneered a type of over-the-air update which is unique. That is a diagnostic tool. So if there's something new that's gone wrong with one of the supplier's parts, we can lab test for a test procedure that would identify the nature of the fault. Then we can code that test in our algorithms, and we can over-the-air that, and we've actually done this. So it's almost like getting a dose of penicillin that the car gets, and it can actually self-diagnose and determine if there is a new fault from a supplier. This is cutting-edge stuff. And more recently, as part of the seminal announcement this week that I made that we're going to get to 5 miles per kilowatt hour, part of that is hardware, but a chunk of that advancement is due to some new motor control software. And we will be over the air relaying that, transmitting that to all our fleet.
So in other words, you're going to improve the efficiency of previously sold cars.
Totally.
And they'll step up to 5 kilowatt hours.
No, they won't all, but they will all improve that incremental part which is due to that software, the effect of that particular software. It's only a car that we're going to launch very soon will have the Magic 5. But they'll all benefit from this.
Really, really interesting. I don't want to put words in your mouth, but I'm going to repeat what you said in your polite British ways, in my coarse American ways. Elon Musk is running 4 companies. He's distracted. Tesla was the leader in all these technologies, battery, motors, software, over the air, down the road. And other than self-driving, they have lost the mantle of leadership, it sounds like you're saying, across the board in EV technology.
Yeah, let me give you some metrics. If you look at for many years, we supplied the batteries to the World Championship for electric motorsport.
This is related to the deal with Aston Martin, or separate?
Quite separate. And we used all that knowledge from 4 years of successful motor racing to all the teams in the World Championship for electric motorsport that we supplied the batteries for. All that expertise has been embodied in our battery management system, our BMS, and our battery systems in our current cars. And actually right today, we supply the front drive unit, the inverter and motor and transmission in the nose of all those race cars. That is the most advanced unit in the world today. It is nearly 15 horsepower per kilogram. If you look at what Tesla's doing with its Plaid technology, it's about 3.9 horsepower per kilogram.
So this is 4x that.
Yes. And if you look at our mainstream production technology that we put in Lucid Air, we get up to 9 horsepower per kilogram. Plaid is 3.9. It's not like we're 30% ahead.
Really, really interesting. So the old philosophy of race on Sunday, sell on Monday,
Indeed.
Still kind of real.
Indeed. And do you know what, Barry, what's remarkable about this? I think that adage was true in the 30s and the 40s and the 50s. But I've been in advanced engineering in road cars all my life. I've always thought it doesn't happen. What goes on the race car? The technology never comes back in. And finally, I've had it happen. And it's genuine. What we've learnt on the racetrack with our battery technology is embodied in every Lucid Air we've ever made.
So let's talk about what took place in your post-Tesla career. You joined Lucid as a CTO. What responsibilities come with that role at an EV shop?
Well, responsibility for the product, for the complete car, engineering the vehicle.
Everything, batteries, motors, and
everything.
Across software, across the board.
Yeah.
I don't think a lot of people realize that Lucid began a long time ago as Ativa. I'm not pronouncing it right.
You are spot on. Yeah.
It was an electric battery maker. How do you explain that transition from just making electric batteries to saying, "Oh, let's become an EV manufacturer"?
Yeah, I think there was a recognition that there wasn't a true value proposition in just approaching that. Actually, Tesla in the early days had a similar approach. So it was only later they thought, well, really the car is the true value generator. So I was approached, would I like to join this little company, which really had very little at the time.
And they had launched in like 2006. They've been around a long time.
Yeah, they'd been around a long, long time. So I was approached much later than that. And it wasn't until 2016 that we really created Lucid and really focused on creating the Lucid Air, the best car in the world. And, it was very clear to me that we'd have to change the name and relaunch as a different brand that was more customer-oriented and facing. So Lucid was founded and created by a small group of us in 2016 out of the little battery company, which had been around for a long time. And that's when we really got serious.
So the co-founder and the CEO of Lucid retires. You're tapped to jump into that role, both as CEO and CTO. What was it like stepping in to replace a founder?
Well, there was a tortuous transition at one stage. But by that time, by 16, so many of my former Tesla team had come across to join me with this mission to create a better car. And I'd been joined by some key players in the team. Derek Jenkins from Mazda. I persuaded Derek to give up his job as design director for Mazda North America and join to head up the design studio. Eric Bach came along, who is now my chief engineer and senior vice president of product and engineering. And these are both brilliant people who joined me pretty well in the early days, and they were through this period with me. And as a little team, we created Lucid. And we launched Lucid Air, it was December 16, and then it was clear we needed to have some serious money to put this thing into production.
Mm-hmm. You raised a lot of capital over the years.
Yes. And it requires a lot of capital. And then we had a lean period through 17 and into 18 where we couldn't find any funding. But we had what turned out to be a very interesting card that had been played. Mm-hmm. Because in 16, I became friendly with the CTO at McLaren. Mm-hmm. And over a cup of tea in England, in the McLaren Tech Centre, English style, we decided that we'd enter the world of electric race cars. Mm-hmm. And McLaren recognised that they've got great race car experience, but they didn't have the battery pack experience. But we'd got the battery expertise.
So let's talk a little bit about that battery pack. It's scalable. It's modular.
Yes.
It continued to iterate based on race experience.
Yes.
How much of an advantage is the Lucid battery pack versus other EV makers?
It's a significant advantage, but the biggest advantage in terms of our range and efficiency is not the pack. It's the motor and inverter and the complete drive unit.
So let's talk about that because, and I'm going to take a look at an engineering drawing,
right.
But when I look at some of the internals for the engine, the motor, and I still say engine out of habit,
yes.
But the motor and the transmission are integrated into one, and the axle, the transmission, goes straight through it.
Yes, the differential.
And so there's no differentials. There's a lot of things that come out of the vehicle with this very small, very lightweight, yet high horsepower, high efficiency motor.
Yeah, yes.
Tell us a little bit about the engineering behind that.
Okay. So one of the disadvantages when we were doing Model S was that there were two different teams. One was doing the transmission, another was doing the motor. So JB Strobel's team was doing the motor, and I was doing the transmission. And so you got two different groups, and where the two join is a weakness. So when I set up Lucid, it was clear we needed to reinvent the electric motor. And I can't tell you, Barry, that at the time that seemed crazy.
It seems crazy just saying it right now. I'm smiling because what do you mean you want to reinvent the electric motor?
I'll tell you why. There was a perception that you couldn't make a better electric motor, that electric motors are so much more efficient than gasoline cars that it's done. It was designed in the Victorian era and that was it. And it is true that electric motors can be very highly efficient. If you put one in an air conditioning tube, you run at a set speed and a set load, it can be right on that peak spot of efficiency. But that efficiency trails off dramatically any side of that spot. And if you look at an electric car, people don't often realize that car goes faster or slower when the motor goes faster or slower. That's what determines how fast you go,
right.
how fast the motor is spinning, and how much you accelerate. That's how much torque is being developed from the motor, how much power is being released, and the antithesis under regenerative braking. And so the task is to create a motor, an inverter system and transmission that's got a much broader bandwidth of efficiency. And this wasn't even considered possible. I don't think anyone was thinking of it.
And you also not only made the motor more efficient, but you integrated the transmission to the motor.
Totally. So the electric motor's got two parts. There's the fixed bit, which is called the stator. They're very simple, and the bit that spins in the middle, which is called the rotor. And the rotor really provides power as a result of how fast it spins and the torque that it transmits at that spin speed. And if you look at something that transmits torque, like a propeller shaft in a car, you're a car guy, you know prop shafts are hollow, they're tubular, because that's what's required. You
want them to be light and modular.
And you learn that the metal in the middle does very little, that's why it's hollowed out. So I started asking, well, what does the metal in the middle of a rotor do if it's trying to transmit torque and it's electromagnetic? Why does we have to have these solid rotors? Why can't we hollow them out more? Well, the answer is it does very little. We can hollow it out. It should be like a tube. And then we start thinking what we can get in. And I have a brilliant engineer, a team on my engineer on my team called Balázs Palfais, Hungarian, who came up with this integrating a micro differential inside. And this was all enabled by my brilliant motor engineer, Dr. Imad Dalala. And I put them both together to sit together. And I said, look, guys, I don't want to have a separate motor and transmission team. I want to consider a motor transmission as a single rotary inertial system. I want to think of it as a single unit. I want a motor transmission unit. And you might think, why do you even need gears? Well, you need gears because the wheels of a car are quite large compared with the diameter of an electric motor. So you need to provide that tractive force at the contact patch of the tyre. And the bigger you make the wheel, the less force you're going to have for a given torque. So you do need to have a reduction set. So we launched Lucid Air with a ratio of 7.06 to 1. Model S was 9.0 to 1. We went to 7.06 to 1 for Air, and we compromised a little bit on 0 to 60, but we got better mid-range performance. And I always wanted more mid-range acceleration and efficiency. I wasn't going to be chasing 0 to 60 with it, and so that's why we went to a 7.06 to 1 ratio.
What's the power to weight ratio of that integrated and very compact motor and integrated transmission?
Well, if you look at the whole unit, there's a drive unit, inverter, motor, and transmission, the whole thing with the differential, it's 9.0 horsepower per kilogram.
That's substantial.
It's substantial, but it's more like 20 at motor level, and if you look at the elements within the motor, it's more like 25 if you actually cut away the motor. So often people attribute that to the motor, but it's not. The motor is about 33 kilograms of the 74 kilograms of the complete unit.
So let's talk about what making that so relatively small and light does to the design of the car.
Yeah.
Not only are we not talking about the hump in the back seat or even in the front seat, but by making that motor so small, the floor panel of the car can be relatively flat. The wheels can be pushed further out to the corner, and the interior cabin becomes much more substantial for a car of this size.
That's right. But we'd done all that with Model S. But what we hadn't done, and this was the impossible step, and we had because electric motors were inherently much smaller than gasoline V8s and the like, and didn't need all these drive shafts, we had all those advantages with Model S. But what I asked was kind of the unthinkable at Lucid. Well, we know that the drive unit, the electric motor and drive unit is a lot smaller. What if we really explored how small we can make this thing? Why don't we just go crazy? Let's see how compact we can make this. Because if we could make it even more compact, we could have an even more profound impact upon the design of the car. And that's when I took perhaps Lucid's greatest gamble.
Mm-hmm.
And this is why I could never have done this in a conventional car company. Because what we did was, whilst one team set off, my motor and inverter and transmission team set off to truly miniaturize that drive unit, the rest of the company, the rest of the engineering and design teams, were designing Lucid Air as a car with enough legroom, transformative legroom and comfort in interior space, but much smaller on the outside. Mm-hmm. Much more aerodynamic and much sleeker.
It's a mid-sized car with the room of a full-size car
It's
inside.
got full-size, its interior space is longer than a long-wheelbase S-Class Mercedes, and yet on the outside it's 10 millimeters shorter than a Tesla Model S. And so I bet the house on we're going to engineer this car and design the whole thing around the will-be size of these drive units, because we will achieve that miniaturization. Otherwise it wouldn't work. And we managed to pull it off, and that's how we were able to do Lucid Air. It was a huge push that the car would only work if we achieved this miniaturization. We had to achieve it to make the car work.
So let's talk a little bit about the Lucid Air, which first came out late 2021. Is
Yes,
that the right
October
date?
21, yes.
500 plus mile range, the longest in the industry.
520 when we launched.
520 when you lost.
Mm-hmm.
Fastest acceleration, highest top speed,
Yes.
lowest drag coefficient, most interior space, most luggage space,
Yes.
and then out comes the awards.
Fastest charging.
Fastest. Well, we're going to talk about the new 200 miles in 12 minutes, which nothing compares to that. But I'm looking at this run of awards from, let's go down the list. Car and Driver, Motorsport, Edmunds, Ward's Automotive, Car and Driver, World Car Awards, Newsweek, U.S. News and World's Report, Bloomberg, Car and Driver, Motorway. It's Best Supercar, Best Luxury Car, Best Electric Car, 10 Best Engines and Propulsion Systems, Top EV Pick, Record for Longest Range Ever Tested, Car of the Year, EV of the Year. Like, you guys have cleaned up as of April 2024, like every award you can suck up for this. So the first question is, when the Air first came out, it was kind of, what can we do if money is no restraint? But then you've certainly come out with subsequent models that are a little more affordable. Tell us about the plan for the next few vehicles that are coming out of Lucid.
Yeah, we were really thrilled because we won Motor Trend Car of the Year for Air, and it's the first time any company in the history of that award has ever won that award with its very first vehicle. No one's ever done that before.
Amazing.
So this was a landmark. And it was important we started with a high-end vehicle first to establish the brand. But when I launched Lucid Air in the thick of COVID, and we did so on September 9th, 2020, I promised the world that we would get to an entry-level price of $69,900. Mm-hmm. And I'm so pleased that earlier this year I met my promise, that we brought the pure version of Air, which is an outstanding car.
$69,000.
$69,900.
What's the range of that one?
The range of that one is 419 miles.
Still not too shabby.
And the reason we're able to do that is that we can achieve that with just an 88 kilowatt hour battery pack. No one else is even close to that.
And that's the efficiency of the motor and the inverter.
Yes, which means we can get 419 miles, which means more than anyone else has got, with a smaller battery pack. For example, a Model S has got over 100 kilowatt hours. And because of that, because the battery pack costs so much to make, it saves us that money. And as a company, we can afford to put that product out there.
So let's talk about a couple more products that are on the drawing board. If we look around and we see Hyundai and Kia, they have 40,000. Volkswagen, 40-ish something. The Model 3 in the 40s. Mm-hmm. We'll talk about the Chinese EVs a little later. But it looks like the average price of a new car in the U.S. is now about $48,000. If you could get in the 40s, it seems like it opens up a mass market. What are the plans?
Totally.
We'll talk about the SUV in a minute.
Totally.
What are the plans for, a really affordable entry-level EV?
Barry, you're describing our mid-size platform. Exactly that. It's scheduled for production late 26. $48,000 to $50,000 car, state of the art, and we'll be able to make that because we can go further with less batteries, and therefore we can afford to make such a compelling car at that price point, like no one else can, embodying all our learning, all the technology that we've developed from Air, and that will transfer all our knowledge into mid-size platform, making EVs progressively more affordable. That is our mission. We want to be a major player. Don't think of Lucid as a niche luxury player. I want to be selling 1 million of those cars a year in the early 2030s.
Give us your spec targets for that mid-size car, which I don't think you have a name for yet.
We haven't.
What is the horsepower? What is the range? And what is the interior space going to be like?
We haven't disclosed that. It'll just be super competitive. But I can say this, that, that will be a time when we overtly compete with Tesla Model Y and Model 3. That will be our Tesla Model 3 and Y competitor.
You want to call that a Model 3 killer?
No, I never call anything.
Oh, all right. No. Again, I'm putting words into your mouth. So what I would imagine...
There's room for both.
What I would imagine would do really well in the market is a car that costs $40-something thousand is the size of an E-Class Mercedes or smaller, with a range 400, dare I say 500 miles and 400 or 500 horsepower. Am I hallucinating, or is that are those realistic?
I think we have to look at the need for range in the future. Paradoxically, I see the electric cars of the future having less range than today and less need for range.
As the network gets built out.
Yes, as you get a more mature charging infrastructure. I never get range anxiety in a gasoline car.
There's always a gas station.
I might have a strange accent, but I have learnt something during my days in the US. There's a gas station on every street corner. I'm not going to run out, unless I'm in Utah, and the next one is
200 miles.
I don't have to worry about getting gas. So when we see a more mature charging infrastructure, and the other thing that's coming is faster charging cell chemistry.
So let's talk about that.
So that's going to help.
The new technology, the Gen 1, not Gen 2 or 3, but the next EV charging system that you're going to have available is 200 miles of charge in 12 minutes.
Yeah, we got that.
That exists today.
Yeah.
So that's a pretty big lift for
Yeah.
for a cup of coffee and a bathroom break.
Totally.
You have 200 miles.
Totally.
What's the next generation after that?
Well, first of all, what I want to say is the way, and I will answer your question, but this is a very important point. The way charging is measured really frustrates me, because everyone is obsessed with measuring it on how fast the percentage of the battery charges, 10 to 80%. Well, it doesn't matter.
No, you want the miles.
It doesn't matter what percentage the battery charges. If your range sucks, your charge rate will suck. So what's important is the power that's going in kilowatts multiplied by your efficiency in miles per kilowatt hour, and that will give you miles charged. Well, it'll give you technically per hour, but it's miles per minute that matters, and we're on the same page. That is the first thing. That's the thing that counts. And we're able to get Gran Touring and get 300 miles range charge in 21 minutes. It's extraordinary. No, we've got the fastest charging thing on the planet. Now, one of the issues with today's cells is that you trade energy for power. So actually, you could have faster charging, more power dense cells, but you'd lose range for that. So we always tend to go for more energy cells, which have got a limit to the charge rate. So
can you do both? Can you have a small number of fast charging cells?
That sort of the benefits cancel each other out. It's a great idea, but you do the math and it doesn't help you. Actually, it actually makes things even more complex. One of the potential saviors here is the growth of LFP. This is the new lithium, the iron phosphate chemistry. Now, iron phosphate has kind of sucked because it's lower energy and it's cheaper. So it's kind of like the cheaper nasty poor man's cell.
Mm-hmm.
And it's been really developed a lot, particularly by the Chinese. And actually, its energy capacity is growing quite healthily of late, and it's got the added advantage it can take a lot of power charging. So I think there's a real argument for lower range cars with LFP cells, a more mature infrastructure. Not
and
been able
very
to go
inexpensive.
so far.
They're much cheaper, right?
Yes. You take a mass hit, but with Lucid's efficiency, then with the mass hit becomes less because we're carrying less cells,
weight. Mm-hmm.
And then you have to charge a bit more often, but it's really fast when you do charge. So you're thinking then about like stopping for 7 or 8 minutes rather than 15 minutes,
mm-hmm.
and so it's going to be more stop and go.
And that's what BYD and the Chinese manufacturers are making?
The BYD, Goshen, there's several. They're really taking a lead in this blade type LFP technology. Mm-hmm. And I think it has its place. I think for a performance premium car, cylindrical lithium-ion cells, NMCs, are the right solution still. And I think they will have their place alongside LFP.
So it sounds like you're fairly impressed with the technology in the EV space coming out of China. I believe, was it last year, BYD passed Tesla for the highest selling EV manufacturer?
I believe you're right.
So China is going to be a force out there. We're not currently allowing those cars into the United States. I don't know if that changes anytime soon. What do you think of the technology that... not just the battery technology, but the whole automobile? Is China going to be a major player in the EV space?
And big new tariffs announced in Europe as well. So my take on China is this, that their vehicle engineering has advanced to a shocking degree, in a good way, in the last 3 years. I can't believe how much better their cars are. Their battery technology for LFP, they're in a leadership position. Their powertrain technology is still several years behind Tesla, and Tesla's several years behind us. But don't underestimate them. If they can transform their vehicle... When I talk about vehicle engineering, I mean fit and finish, door slam, wind noise, ceiling, materials, comfort in the seating.
Let me interrupt
like
you
that,
right there.
Traditional attributes.
Let me interrupt you. The thing that I have been so impressed with the Lucids I've seen is you not only come from an automotive background, whereas Tesla is a little more of a technology background, but it feels like a luxury car. The fit and finish is outstanding. The materials is excellent. It's obvious you want to compete with Mercedes, not Tesla.
Totally.
But the thing I have to ask about is the U.S. has shifted to a giant SUV market. Tell us about Gravity. When are we going to see the first SUV with a 400 or 500 mile range from Lucid?
Yeah, and first of all, about the luxury, we wanted to endow the car with a quiet luxury, an understated luxury, but really high quality materials in a very understated sort of a California-inspired design sensibility. And that's often misinterpreted as it's not true luxury. Well, it's not ostentatious luxury, no.
Right.
It's understated quiet luxury. So moving on to Gravity, you ask. So Gravity is scheduled for start of production late this year.
Oh, really?
Yes, absolutely. It's going to be our seminal product. It's going to be the best SUV on the planet. Nothing less will suffice.
When will consumers first be able to purchase these?
We haven't announced precise purchase, start of purchase. We're scheduled for start of production late this year. Realistically, the ramp up in production will take place during the early part of next year. So watch this space for an announcement in terms of availability.
And are we aiming about a comparable price to the Air?
Yeah, I see a starting point of just under $80,000 for a variant of Gravity. Absolutely, that's essential.
And I know I only have you for about 5 minutes. I have to ask one question that we didn't get to. You're the CEO of a public company. I know that comes with all sorts of obligations and, dare I say, headaches. How do you feel about being public? How is your capital set up? Are you comfortable that you could go the distance to the 2030s? What are your thoughts about being a public company and having access to the capital markets?
Well, I take my responsibilities very seriously. It is a weight on my shoulders, but it's one that I can carry. I'm comfortable with what we're doing. I think we can conduct ourselves in an incredibly ethical manner. I'm very committed to this company, and I'm all in. I've never sold a single share in the company ever, other than
and it had a giant run-up when it came public with the SPAC and came back down.
Yes, actually, and actually that triggered some of my performance stock options, which were based. My stock options performance package was based entirely upon share price, and so all that remuneration was due to performance-related stock options, which I triggered. I've not sold a single share other than ones that I just had to for tax purposes, and so I'm all in on this company. I'm resolutely optimistic. I think we've got the best car in the world at the moment in the Lucid Air. We're outselling Porsche Taycan and Mercedes here in the US. We're outselling BMW i7. We're outselling the e-tron GT. Mm-hmm. And this is a company that many people still haven't even heard of, Lucid.
Any plans for a two-door coupe, a sports car?
I'd love to do it, but we've got laser commitment. We have to focus on the big ones. Gravity. Mm-hmm. So we've got Air now. Gravity's coming. And then the really big one, the mid-sized platform, the more affordable $48,000, $50,000 car. We've got to have laser focus upon that. And something else, a technology roadmap, which excites me the most, because no one else is staying still. This is a technological race, mm-hmm. and we have to keep running, because if you don't run, others will catch you up. And the best defense we have is to keep our tech roadmap intact, and that's what excites me the most.
So last question before I let you get on with the rest of your New York tour. Take me to the early 2030s. Where do you want to be in units you're selling? How many different models do you want to sell? What does Lucid look like 7 years from now in 2031?
I believe we can be a healthy company. I think that what is not recognized is that our technological advantage today, which is seen as a burden, it will become a cost-down enabler, and therefore we will be able to operate at a better gross margin because of that. Our very technology will be a gross margin enhancer, which will give us a profitability edge, and by the early 2030s, I'd like us to be selling no less than 1 million cars a year, because that's what it takes to have a meaningful impact upon the environment. But I also want this multiplier effect with our tech licensing business, because what the world needs is the $25,000, $30,000 car. And I don't think that's the business we, Lucid as a company, and our shareholders deserve, because it's all about volume, low margins. But I think others could manufacture that, having access to our world-leading technology. And with that multiplier effect, we truly can have an impact upon the environment and therefore the future of mankind.
Fascinating stuff. Thanks, Peter, for being